Now that we've reviewed positive beam notation, and we're just going to go back right now to what we learned in statics. So we have our normal, we have our shear, we have our bending moment, normal, shear. I'm going to repeat this again because I say this all the time. You should never have a wrong answer in statics because the sum of all of our forces and moments equals 0. So if I want to know at this point what the internal forces are, I can actually work this problem from left to right, calculate, right to left, calculate. Guess what? These should be the same numbers. The other thing is just a reminder, when I draw a free body diagram of my loaded system, okay, when I look at an overall free body diagram, it does not include internal. Because when I put this beam slice back together, I'm going to have a normal that's pulling to the left, okay, a normal that's pulling to the right. And when I use equilibrium, okay, the sum of a left and a right is going to be 0, okay? So there's a difference between, I'm assuming positive behavior, and if I get a positive normal, I know that I'm in tension, and I'm summing forces in the x direction, and I have this rule. So over here, if I'm looking at this left side, when I'm summing forces in the x direction, it will indeed be a positive n because I am using my rule of going to the right. When I sum forces in the x direction on this right-hand side, it's a negative n for equilibrium, okay? There's a huge difference between positive force notation, so I can figure out what my behavior is, and then the rules that I use for equilibrium, okay? So let's just look at a really quick beam right now. We're just actually going to look at a cantilever, okay? And we are going to load this cantilever 3, 4, so we know that's 5, 100 pounds. And I want to know at point B, which is 10 feet back, what my internal forces are. So when I look at this, okay, overall free body diagram, I could actually come on here and find my reactions, okay? When I look at B, I have the choice of drawing from the left or drawing from the right. If I draw from the left, I have to include these reactions. But we all know I'm super lazy. And if there's a quicker way to do something, that's what I'm going to do. Because it's a cantilever, I can draw from the right, and I don't even have to worry about these reactions. So I'm going to just go ahead and draw this, and I'm going to simplify it so I have 4/5 of 100, which is 80 pounds. And I have 3/5 of 100, which is 60 pounds. And I have 10 feet. Positive notation, positive notation, positive notation. So now that I have my positive notation and I have my free body diagram drawn, I can start with my rules. Summing forces x equals 0, summing forces y equals 0, and summing moments equals 0. So on the left, all of the forces, they have to equal 0. So I'm going to go left to right. In. Okay, yes, I showed tension behavior. That is not the same as trying to find equilibrium forces. So I have a negative n minus 60 pounds equals 0. So I want to isolate the n. I'm going to take it over. So I have n equals negative 60 pounds. There's my answer. Okay, positive or minus, magnitude, unit. I could also say 60 pounds compression because that's what negative means. Now I'm going to sum forces in the y. I have a v is going up, minus 80 pounds equals 0. So my shear equals 80 pounds. I'm not going to put the plus in front because I know that if there doesn't have a negative, then it's a positive. But again, I'm not showing direction. I assumed positive, I got positive. it's up here, but again, if I were to look at this side, down is positive. So what does up or down mean? I have to then go back and look at free body diagrams, and it's easier if I can just say it's 60 pounds of compression on this system. So now we're going to sum moments. So I'm using right hand rule positive. About this point, so I have a negative moment. Yes, it's positive behavior, but for summing forces, summing moments in equilibrium, it's negative. Okay, these don't count. They're there. Their distance is 0. Minus 80 pounds times 10 feet. Vertical going straight through equals 0. So I have that my moment equals, put it over there to isolate, negative 800 pound feet. Okay, that's how I'm going to report my answer. I know that that negative means it is going to have a curvature that looks like a rainbow or a sad face. And if I go back up to my original drawing, I can again see, oh gosh, if I were to stand on this diving board, it is going to curve down like that. So the whole system has negative moment.